So let's take a look at the metric review problems and make sure that everybody got the correct answers. So if you're converting, let's start with number one. If we're converting 16.2 millimeters to micrometers, we're going from milli to micro. That would be 3 decimal places. Now the question is to the right or to the left. So if you're going from a larger unit, milli, to a smaller micro, that means we need to move the decimal to the right. So that would be moving the 16.2, add 2 zeros, and then you have your 16,200 micrometers. So 16,200 micrometers. If we go from centimeters to millimeters, that's 1 decimal place only, and we're going from a larger to a smaller unit, so we need to move 1 decimal place to the right. So again, if you go from larger centi to a smaller milli, then we're going to have more of those. We just have to decide how many decimal places more, meaning to the right. So in this case, it's just 1. From centi to milli is 1 decimal place, and so we end up with, oops, how did that happen? 2,140 millimeters. Now if we go on 3, from centimeters to meters, we're going from a smaller to a larger unit measure, and that's we need to figure out how many decimal places, and in this case from centi to the base unit is 2, and now we need to move a decimal place to the left. So we're going from 214, so we're going to move 2 places to the left, so we end up with 2.14 meters. On 4, 12.2 liters to milliliters, so from base measure to milli, we're going from a larger to a smaller unit measure, so we have more of those by 3 decimal places more, so we end up with 12,200 milliliters. 5, we're going from 12.2 liters to microliters. Now we're moving the decimal point by 6 places. From the base measure to micro is 6 decimal places, and we need to move to the right because we're going from a larger to a smaller unit measure. So we will end up with 12,200,000. So there's a couple ways you can write this. So it will be 12,200,000 microliters. It's kind of annoying to write all these zeros, so you can do scientific notation. And in this case, you go 1. So let's make the scientific notation 1.22 times, and now you need to count the zeros. So we'll to the decimal points 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 microliters. So you can do that too. If you go from milliliters to microliters, we have 3 decimal places, and we're going to the right, so that will be 12,200 microliters. If we go from 12.2 milliliters to liters, now we have also 3 decimal places, but now to the left, so that would be 0.0122 liters. So 3 decimal places to the left. If we go from meters to micrometers, we have 6 decimal places to the right, so that would make it 16,200,000 micrometers, or you can write that as 1.62 times 10 to the 7th micrometers. That is, let's put the units right here, micrometers, and up here was microliters. If we go from millimeters to nanometers, that is 6 decimal places, and it will give us the same number as what we have on 8. So 16,200,000, and again, you can write that number in scientific notation. It will be 1.62 times 10 to the 7th. In 10, we need to convert 100 degrees Fahrenheit to degrees Celsius. And the way that works is we're going to take the Fahrenheit minus 32. So 100 minus 32, I'll calculate that, and then multiply that number times 5/9. And that will get us, let's just do 1 decimal point, that would be 37.8 degrees Celsius. If we want to convert 98 degrees Celsius, that's close to boiling temperature, to Fahrenheit, then we need to go and take the Celsius degrees, 98 times 9/5. once we have calculated that, and then we're going to add 32 to that number. Comes out to be 208.4 degrees Fahrenheit. Next step on 12, let's convert 1.5 grams. So here on 12, for that calculation, we need to take the 1.5 grams and divide it by 453.39, which is given to you on the top of the page. Is the conversion between grams and pounds. And once we did that, then we come up that we are at 0.0033 pounds. 0.0033 pounds. So that would be 1.5 divided by 453.39. If we are converting from milligrams to grams, we're going 3 decimal places, and that will be to the left because we're going from a smaller to a larger unit. So we have 0.012 grams. And from grams to micrograms, we're going 6 decimal places to the right, and that will be 12 million micrograms, or you can put that in scientific notation. That would be 1.2 times 10 to the 7 micrograms. On 15, 12 milligrams to micrograms, so that's 3 decimal places, that's 12,000 micrograms. And from 0.75 liters to milliliters, we need to move the decimal 3 places to the right, so that's 750 milliliters. And 0.75 milliliters to microliters, that's also 3 decimal places, and that also gives us 750 microliters. So we're done with page 7. Skipping here to part B of the metric review problems on page 17. Problem number 1, converting millimeters to micrometers. So more of the same. We're going to move from milli to micros, smaller units. So we're going to have more of them. We're going to move the decimal 3 places to the right. So we are at 6,789 micrometers. 0.6 millimeters to centimeters. From milli to centi is just 1 decimal place, and that would be to the left in this case because we're going from smaller to a larger unit, so we have fewer of them. So it's 0.06 centimeters. Centimeters to meters, we have 2 decimal places to the left, and so that puts us at 3.568 meters. From liters to milliliters, we need to move the decimal 3 places to the right. So we'll go from here, 1, 2, 3. Now we are at 236 milliliters. And here, number 5, this is actually pretty important. You need to note these equivalencies. 650 cubic centimeters equals the same number in milliliters. So a cubic centimeter is an equivalent measure to milliliter. So you can say 650 cc's or 650 milliliters would be the same thing. And from milliliters to liters, so now we need to have moved the decimal 3 places to the left, and that would put us at 0.65 liters. 60 miles to a meter, so we need to have the conversion on that. The conversion from miles to meters is there are 1,609 meters to 1 mile. If I plug that in, so it's actually, to be accurate, 1,609.344 meters to a mile, so times 60, that comes out to be at 96,560. Let's just round this, 0.6 meters. And if I want to convert that into kilometers, I'm going to have to move the decimal 0.3 places to the left, and that puts me at 96.5606 kilometers. And now inches to centimeters, there is 2.54 centimeters to 1 inch. So we need to do the 45 times 2.54, and that would put us at 114.3 centimeters. To millimeters, I need to move the decimal 1 place to the right, and that would put me at 1,143 millimeters. On 8, the conversion from pounds to kilograms, you're going to have to divide the number by 2.2. That's the conversion factor. So 28 pounds 28 divided by 2.2, and that puts us at, that's 12.727 kilograms, and then move the decimal 2 places to the right to get the grams, so that would be 12,727 grams. On 9, this is also an important thing to know. When water is at its highest density, which it is at 4 degrees Celsius, then its density is exactly 1 gram per milliliter. So that means 1,350 milliliters of water at 4 degrees Celsius weighs 1,350 grams. And at room temperature, it's a little bit off, but not enough to where it would be of concern for us. So whenever you have a volume measure for water or something water-based, a solution, you can make an equivalency of milliliters to grams. So 1 milliliter or 1 cc of water would weigh 1 gram, and that's a good thing to know. On 10. 98.6 degrees Fahrenheit, that equals 37 degrees Celsius. That's human body temperature, so that would be 37 degrees Celsius. Room temperature is about 21 degrees Celsius, and that in Fahrenheit temperature, we can do this conversion real quick. So that's 21 times 9/5 plus 32, and that comes out to 69.8 Fahrenheit, and that's pretty much room temperature. How tall are you in inches? Let's use me. I'm 70 inches tall, and in centimeters that comes out, so 70 times 2.54, that comes out to 177.8 centimeters. Okay. So that's 70 inches is 177.8 centimeters. How much do I weigh in pounds? I'm not going to tell you that. So if you want to find that out for yourself, weigh yourself and then divide that number, whatever the scale says in pounds, you're going to divide that by 2.2 to get the kilograms. But I'm not going to tell you my secrets. So 14. For each of the following, place a decimal point so that the statement is plausible. Samantha is, well, what makes sense is that she's 165.45 centimeters tall. Samantha weighs 68.27 kilograms. That makes sense. The ambulance sped by at 123.4 kilometers per hour. A hot day is about 40 degrees, 40.0 degrees Celsius. And something good to know, sort of have a mental image of the size of a meter. So picture a meter stick, if you know what that looks like, or picture something that's slightly bigger than a yard. A kilometer is times 1,000, so that's 1 times around the track is 400 meters. So 2.5 times around the track, that's about a kilometer. A millimeter on the mental image, it's about the thickness of a penny or a small key. A meter, again, picture that meter stick, or a little bit more than a yard. And a milliliter or cc versus a liter. A milliliter is about 30 drops, not that much. A liter is 2 of those smaller 500 ml water bottles, or 1 bigger liter-sized water bottle. A gram, picture a small paper clip. And a kilogram, well, 1 liter of water, that would weigh 1 kilogram. So that's sizable. And a milligram, that's just a grain of salt. A gram is about 30 drops of water, something like that. And if you take a page or lab manual, measure that out in centimeters, you'll get something like 22 centimeters by 28 centimeters. If you convert that to millimeters, then you just have to add a 0. So move the decimal place one place to the right. So then we have 220 millimeters by 280 millimeters. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. And room temperature is somewhere between 20 and 25 degrees Celsius. Okay, so that concludes our first lab. Keep in mind that you will have a quiz on this, and the quiz will be mostly focusing on the metric stuff. There will be also some stuff from lab number 2. I'm going to combine labs 1 and 2 with the statistical analysis and some of these other items. I will combine that on the quiz, but for the quiz you can expect quite a few metrics problems. Don't worry about conversions. questions. If you need to convert something, I will give you the conversion formula, but you do need to know how to move the decimal back and forth to the right and to the left, and by how many places you would have to move it. So stay tuned for lab number 2, and we'll talk more about this.